Hi everyone, welcome to summer session 2. This is Math 150 and this is going to be the first video for the first week and the first day. So just a brief introduction, what we are going to be doing over the next few weeks. This course is going to be a study of simple geometric objects and mostly they will be within the framework of functions. A function is something that you were introduced to in Math 103 and you looked at more concrete examples in Math 135. So in a very basic sense, why we study functions is because it's a very fundamental tool in mathematics. And it's a rule that governs the relationship between inputs, for which we use the word x, and outputs, for which we use the word y, or the letter. In the simplest of scenarios, we have one input and one output, and we express this relationship between them by writing y equals f of x and reading it as y equals f of x. We use x as a variable to represent the input, y as the output. One way to remember that is the input comes before output, and alphabetically speaking, x comes before y. F represents the rule or the function itself. Now, when inputs and outputs are numbers, we are able to visualize them in the form of what is called a graph. This is again something that you are familiar with. For example, if I were to ask you to graph this function y equals 2x plus 1, one way to do that would be to make a table. So let's say when the input is 0, the output is 2 times 0 plus 1, which is 1. When the input is 1, the output is 2 times 1 plus 1, which is 3. When the input is negative 1, it's 2 times negative 1, which is negative 2 plus 1, which is negative 1. And then we are able to plot this in what we call the coordinate axis, where you have x and y, and you number them. So this is 1, 2, 3, negative 1, negative 2, negative 3, 1, 2, 3, negative 1, negative 2, negative 3. And we write these as pairs of points. So this would be 0, 1, where the first is x and the second is y. 1, 3, and negative 1, negative 1. So 0, 1 is right here. 1, 3 is right here. Negative 1, 1 is right here. Now, if you were to make this table with a bunch of different points, what you would get is a solid line. But you already know this, that this is in a y equals mx plus c form, which represents a straight line. Now, you may not always have a linear relationship. Right? For example, graph this function. Now, I'm going to give you the solution. The solution looks like that, which is half of a circle. And these are ideas that you have already been exposed to. So let's look at what can we build with these objects. Yeah. If we have one straight line, try and list down what you know about a straight line. Some guidelines would be, what's the equation of a straight line? What does the graph of a straight line look like? What is the idea of slopes and intercepts in a straight line? So this, I want you to fill in with the information that you've learned in your prior classes. Once you've done that, now we come to the next idea, which is, that was one straight line. What if we have two straight lines? What are the things that can happen? Yeah, there are three distinct pictures that can be drawn. And now there's a question for you to think about. What is a characteristic feature for each of them? You know, I'm calling this case 1, I'm calling this case 2, and I'm calling this case 3. Yeah. So over here, you can fill in the special names that these have. Again, this is something that you've done in Math 103 and or any other math class that you've taken before. So what I'm trying to introduce here, more than the knowledge, like what these are called, because you've already been exposed to that, is this method of studying where you look at objects and then you look at the relationship between them, right? So, for example, if I have one line, it can only be related to itself, so that's one straight line. However, if I have two straight lines, now I can talk about what is the relationship between these lines. So you have this one case, you have this other case, and you have this third case. Right, so that's a general way of studying mathematics, is you look at objects and then you look at their relationships. So with that done, now a natural question to consider is, what about the case with three lines? Now here's a bonus question. How many distinct drawings can be made with three lines? Okay. Now when you look at these drawings, there's going to be one particular case where three lines enclose an area and a figure is formed which is given a special name, which is called a triangle. So the major focus of the first week of this course will be to study these objects which we call triangle. Now why are they important? First of all, throughout history, the study of triangles is important because it is the simplest closed object we have, right? Because if you take two lines, it's not closed, it's open. But if I take three lines, then I have this region that is closed by the triangle. And in addition, all complex objects can be, those that are specifically made out of straight lines can be broken down into triangles. For example, I can break this into two triangles, triangle 1 and 2. I can break this into three triangles. I can break this into four triangles. Okay. Now the manner in which you break them down may not be unique. So if I were to ask you to submit how you did all of these, your drawings may not match with mine or with your classmates. Yeah. But which is fine, because all we are saying is that this shape is important because if you take complex shapes, you can break it down into triangles. More specifically, you already know that this is a triangle. This is a triangle. Here's some naming conventions. We use capital letters for the corners, also called the edges. And then we use small case for the sides, and we follow this pattern where if this edge is labeled A, then the one opposite that is going to be small a. If this is B, the one opposite that is going to be small b. And if this is C, the one opposite that is going to be small c. Again, it's a convention to make communication easier. It's the same reason why people have names, right? So it's just so you know how to refer to them. Now, another idea in mathematics is whenever you have a new object, which in this case is this triangle, we want to break it down into its fundamental qualities or quantities that characterize it. So in this case, in a triangle, the fundamental things that we are going to talk about are sides and angles. And every triangle has three sides and three angles. Three-angle name actually gives it the name, right? Triangle, meaning three angles. Okay, so I'm going to stop this video here. In the next video, we are going to look at what it means to measure sides and what it means to measure angles.